Hello viewers, this is Christabel Dina from Trinity Software. In this video we are going to see about cryptography, the types of cryptographic algorithms and the security services which are supported by cryptography. Actually, cryptography is used in our daily life. It is to protect our data. The data in the sense the mail we are sending, the Facebook, WhatsApp conversations and online transactions. So this is to secure your data from online hackers and criminals. So how this security is provided? The word cryptography, crypt represents secret and graphy represents writing. So the data is converted into a secure way such that the hackers will not be able to retrieve your data, that is your sensitive data. So let us see the terms involved with cryptography. We have four terms: encryption, decryption, plain text and ciphertext. So what is this plain text? Plain text is the simple message which we are going to transfer to the recipient in a secure way. So in this case, meet me at 4 p.m. is a message from A to B that must be transferred securely. So the sender A uses an encryption algorithm, uses an encryption process. It consists of two things: encryption algorithm as well as a key. Using both this encryption algorithm and key, you get the ciphertext. So if you see here, the ciphertext, it is in plain. It is a combination of numerals, alphabets and symbols. It is readable, but it cannot get any message from the ciphertext. That is, it is being encrypted and it is secure. No one can read the message and understand what is given there. So how you can retrieve the plain text? So this ciphertext is taken. You have to apply a decryption algorithm, corresponding decryption algorithm and some key. In this case, the same key used for encryption is used for decryption purpose also. So after applying the decryption algorithm with the key, you get the corresponding plain text. Okay, so this is, now let's see the types of cryptographic algorithms. We have three types. The first one is secret asymmetric key cryptography, where one key is used for both encryption and decryption. These are some popular algorithms used for symmetric key cryptography. And public key cryptography, asymmetric, as the name represents, you have two keys used here. One is used for encryption and another is used for decryption. The popular examples are RSA, ECC and all these things. Hash function. Here in hash function we are not going to use any key. Just you are going to take the message, apply the hash function and you will have a fixed length hash output. This is to ensure integrity of the message. The examples are MD5 SHA, RIPE-MD and WorldPut. Now let's see all these things in detail. So secret key cryptography, I am taking a simple algorithm for this. The sender takes a simple plain text hello. It is encrypted with the key value k is equal to 7 and we get a corresponding ciphertext. So this is transmitted to the recipient or to the receiver using the decryption algorithm with the key k is equal to 7. The receiver will decrypt and get the plain text back. So the algorithm used here is Caesar cipher or substitution cipher. You will see how this Caesar cipher algorithm works with k is equal to with key value is 7. At first all the alphabets are translated to numerals from 0 to 25. A represents 0 and it goes on till Z. Z value is 25 and this is the algorithm. Algorithmic representation, mathematical representation of Caesar cipher. Here this X represents the numerical value of the corresponding alphabet and key k represents a key and D of X is again decryption, X minus k algorithm is used. So what happens in the encryption? We are taking the plain text and you are converting that into alphabet number. So the corresponding numerical value for H is 7 and we are adding that with the key value 7 and we get 14. Similarly for E, the value for E is 4 and you are adding 7 and you get 11. So now the corresponding alphabet number for 14 is O. Similarly for 11 it is L and hence we get the ciphertext as this. So the encryption process is this and decryption works in the reverse way. We have to take the ciphertext, then apply the alphabet number, numerical value and subtract the key from it and you will get back the plain text. This is about sees a cipher, the key value can be anything from 1 to 25. So that is about secret key cryptography. How public key cryptography works. As I said already, different keys are used for both encryption and decryption. Every user will have one private key which is kept secret and public key which can be shared with anyone. The interesting property of this public key cryptography is that it is impossible to determine the decryption key just by knowing the encryption algorithm and the encryption key. So if you know the cryptographic algorithm used and the encryption key, you should not be able to determine the decryption key. So let's see how this public private keys work. So we have two users here. Anita, she has generated her own private key and a public key pair. Priya also has her own private key and public key. Now Anita will have a public key ring. So it consists of the public keys of all her friends who have shared their public keys with Anita. So in this case, Ajay, Rose, Neha and Priya have shared their public keys with Anita. So Anita maintains a repository of these public keys. Similarly, Priya's public key ring will have the public keys of her friends. So what they can do with these public keys? The first thing that can be done is encryption to ensure confidentiality. The main purpose of cryptography is to provide confidentiality. That is, the message should be read only by the intended receiver. It should reach only the intended receiver and not read by anyone else. That is confidentiality. We will see how this can be achieved. So Anita takes a simple plain text, hello Priya. So her motive is that hello Priya plain text must be read only by Priya and not by anyone else. So she takes an encryption algorithm, say a popular algorithm RSA. She uses Priya's public key to encrypt it. So she will get a corresponding cipher test. That cipher test is transmitted through unsecured channel. So now Priya on the other hand will take this transmitted cipher test and applies the decryption algorithm using her own private key. So if you see her using her own private key means Priya's private key will be kept secret by Priya. It will not be held by anyone else. So only she can decrypt it and she can read the plain text. This is about achieving confidentiality. Next, authentication is that the message has been sent only by the intended sender, not by anyone else. That is, the sender has to prove his or her identity, that this message has been coming from him or her. Again, the same example, Anita is sending a plain text, hi, I am Anita. She is proving herself using this plain text. So she takes an encryption algorithm and the key used here is her own private key, so that Anita's private key will be available only with her, not anyone else can encrypt it with her private key. So the cipher text is obtained and it is transmitted over the unsecured channel. Priya takes this and applying the decryption algorithm using Anita's public key, she can retrieve this plain text. In this case, not only Priya, anyone who has the public key of Anita can retrieve this plain text. That is about authentication. Authentication means that I have to prove that I am sending the message. That's it. Anybody else, anyone can receive the message. That is authentication. And the third type is hash function to ensure integrity. That is, message is not being altered in between. In order to ensure that, we use the hash function. Let us take an example message M. It can be of any variable length. You have a hash function that has some requirements. The output of the hash function will be a hash value which is of fixed length. So this is a simple mathematical representation of hash function. Let's see what are the requirements for a hash function. The input can be of any length, variable length. The output will be a fixed length. For example, if we take SHA-256 algorithm hash function, it gives an output of 256 bits only, irrespective of the input message. And h of m is relatively easy to compute for any given message m. And h of m is one way in the sense you can calculate h of m from m, but not the reverse process. Given h of m, it is impossible to retrieve the message m. H of m is collision free. You cannot find out two messages x and y such that their hash values are same. That is computationally infeasible. So So these are the requirements for a hash function. So in general, cryptography supports all these security services: confidentiality, authentication, integrity. These can be supported using the symmetric and asymmetric cryptography and the hash function. Non-repudiation is another important security service, which means that sender non-repudiation means that the sender cannot deny that I have not sent the message. So that is non-repudiation. So we will have a proof that the particular user has sent some message. So that is about non-repudiation from sender side. Non-repudiation from receiver means the receiver should not deny that I have not received the message. That is about non-repudiation. So this is about the cryptography. Thank you for watching. If you have liked this video, kindly subscribe. Thank you.